So today we're going to be looking at section 6.2, trigonometry with any angle. Let me try to refocus that a little bit. And so we looked at the unit circle the other day, the periodic functions. What is a periodic function? Let's start with that. A periodic function is a function if there exists a positive number, some number, in this case we'll call it c, such that if I take the value of the function at some t plus c, I get the same values if I had f of t, or any value t in the domain of f. So in other words, I just get back the same answer. It repeats itself. The smallest value of that c where this occurs is called the period of the function. And the reason we talk about this is because all the trig functions are periodic. Okay, all the ones we're looking at are going to be periodic. What are the periods that we're talking about? Okay, the period for the sine, the cosine, the secant, and the cosecant. Because remember, these two are just the reciprocal functions of these two, so they're all related, is 2 pi. And for tangent and cotangent, it's just pi. So this is the period for each of these different functions, and that's going to be an important concept for us, so we want to make sure we remember those things. So why is it 2 pi? Okay, well, it's 2 pi because of our unit circle. One time around the unit circle, if you remember, is 2 pi. So if I start right here and I start going around the circle, remember, this is the cosine value for this angle, and this is the sine value for this angle. So as I go to each of these values, the sine and the cosine is related according to those points. And then when I go around the circle one time, what happens is I start doing coterminal angles. Okay? In other words, angles that terminate in the same spot, so it's going to have the same answer. So, and that occurs every time I go around the circle, which is an angle of 2 pi. So the period for the sine and cosine is 2 pi. And then because the secant and the cosecant are related to it, it is also 2 pi. The reason why the tangent and the cotangent are only pi is because, remember how it's defined, it was y over x. And so it kind of cuts things in half a little bit. And so it repeats every half circle. So this would be one complete time. And then when I come down here, I'm going to start repeating those values. And we'll discuss that a little bit more detail later on in another chapter when we start looking at the graphs and things. Okay? But for right now, I just want to make sure we understand that for the sine, cosine, secant, and cosecant, the period is 2 pi. And for the tangent and the cotangent, the period would be pi. And that's because of the unit circle. So because of this, we can use this periodic nature of these trig functions to find the trig values without using a calculator for many other angles. And so that's what this first lesson is about. And then we're going to do some more of the same types of problems that we talked about the other day. So let's look at these problems over here. Start with this one. So down here at the bottom. So with the idea of the periodic nature of things, let's look at what is the sine of 9 pi over 4. Okay, 9 pi over 4. So this is the long way. We won't do it this way, but I'll show you how this all comes about. So 9 pi over 4. Again, think fractions. So we know that 2 pi is the period, and 2 pi as a fraction is 8 pi over 4. Okay, so knowing that, we can take this and break it down into then the sine of pi over 4 plus 8 pi over 4. That's 9, correct? 1 plus 8 is 9. And so what you're seeing here is that's the period right there. Okay, and so this is equivalent to the sine of pi over 4. And the sine of pi over 4, we can see off of our unit circle, is the square root of 2 over 2. So because 9 pi over 4 is coterminal to pi over 4, they have the same sine value. That's really what it boils down to. And so we can do all of these angles that are in here. So the next one we had here is what the cosine of a negative 8 pi over 3. Okay, so it's about finding what angle is this coterminal to. So there's a couple of ways to do this. If you're learning the unit circle, to get a smaller one here, but 8 pi over 3 is negative. So what I usually do is think about this whole thing. So if I start here at 0, a negative is in the negative direction, okay? And 1 time around is a negative 2 pi. Well, as an over 3, that would be 6 over 3. So a negative 6 over 3. So if I go this way, that's a negative 6 over 3. And then go to this one, would be negative 7 over 3. And you can go to this one, and that would be negative 8 over 3. So this is where it's coterminal at. So just count the thirds as you go around. 1 time around is 6 over 3, 7 over 3, 8 over 3 in a negative direction. And so I can see that I'm coterminal right here at this. Okay. And so then what would be the cosine of this angle is a negative 1/2. And so I can come over here and say this is a negative 1/2. And write that down. And so that's how I can find these angles. The rest of them are just more of the same stuff. And you can count them. You can go around them. We can take more questions on this if you have it during class time. The next thing I want to look at is just an extension of the same questions we did the other day. In 6.1, we did some of the easier ones. So now we're going to look at some of the more advanced ones. How do I find the 6 trig functions from this picture right here? Okay, so we'll start with this one right here. And let me go ahead and do this problem over here. I'll kind of give it a quick picture. So we have this, we have an angle. It's set down here. The point on the circle is here. It's a negative 12 over 13 and a negative 5 over 13. And I want to know the 6 trig functions for this angle, theta. Okay, so what was the process we're going to follow? So I want to make the right triangle to the x-axis. This is the x, this is the y. We need to find r. So the first step is to find r. So by Pythagorean theorem, r is the square root of x squared plus y squared. X squared is a negative 12 over 13. This is a negative 5 over 13, so we need to work this out. So negative 12 squared is 144. This is 169. And so what I have right now is 144 over 169 and 25 over 169. So combine these up and you end up with what? 169 over 169, which is equal to 1. So r is equal to 1. Okay? So with that in mind, we now can do our 6 trig ratios. I always start with the sine of the angle. The sine is y over r. So this divided by 1 is just this. So I just simply just write negative 5 over 13. The cosine is x over r. There's that. The tangent is y over x. So a negative 5 over 13 divided by a negative 12 over 13. And as you work this out, you flip the bottom and multiply. You end up with, and a negative negative is positive, you get 5 over 12. Do the reciprocal ones. So the cosecant of theta is a negative 13 over 5. The secant of theta is a negative 13 over 12. And the cotangent of theta is 12 over 5. Okay, so that's how you do it. So part of everything that we're doing right here is about how do I find these trig ratios based off of these different scenarios. So this one is very similar to what we did the other day. This is what you kind of did the other day, where I gave you a point on the terminal side of an angle. You find r, and then you can do the ratios. So, and I drew the picture for you. So in number 3 in the classwork, I just give you the point. Find the sine, cosine, and tangent. So we're not going to do all 6. We'll just do the first 3. Okay. You now need to do the rest of it. So what should I do? Well, draw the picture. Graph the point. 3, -2. 3, -2. It don't have to be perfect. It just has to be symbolized for it. So this is 3, -2. So this is the angle we're looking for. That's theta. Because all the angles are in standard position, okay? I don't need to have this big circle out here, but the process is exactly the same. I need to find this distance, okay? I got to find that r, and you can draw the right triangle to the x-axis if you wish. And so what is r? Pythagorean theorem says it's x squared plus y squared. X is 3, y is -2. I want to see this point right here. And then I can just give me this answer in the simplest radical form. This is 9 and 4 is 13. The square root of 13. And so from that, I can now answer the rest of these questions. What is the sine of theta? Y over r, -2 over the square root of 13. What is the cosine of theta? X over r. And then what is the tangent of theta? Y over x. And so that's how you would do that. And then you just do the reciprocal ones. You might want to rationalize these. So you'll get -2 radical 13 over 13 and 3 radical 13 over 13. Making sure everything reduces and you're good. Okay? So what about the other ones? The other ones give you clues. So you still do the same thing, but it's from a different starting point. So in this one, number 4, I got to do all this. I got to find that point on the terminal side, but I only have these clues. That's all I have. Okay, so how do I use these clues to get it to look something like that? Well, it's all about the signs and what these functions mean by definition. So here I have the cotangent is -3 and the cosine is always greater than 0. So let's go and take a look at those clues and write them out. So we have the cotangent of an angle is -3 and the cosine of that angle is greater than 0. So what does this mean? Well, the cotangent by definition is related to x over y. Okay, so we're going to start here though. It says that the cosine of the angle is greater than 0. So in our unit circle, in our coordinate system, the cosine is x over r. So the r we know is always positive. So for the cosine to be positive, greater than 0, x has to be greater than 0. And the only two locations in the coordinate system where the x is greater than 0 is in quadrant 1 or quadrant 4. So this tells me that the angle has to be in quadrant 1 or in quadrant 4. Now, let's go look over here. So we've just found out based off of this that x has to be bigger than 0. So when I go to the cotangent, where it's defined as x over y, and I get a negative answer, well, that tells me that the y value has to be negative because x was positive. So y has to be negative, and the only place of these two quadrants where y is negative is in quadrant 4. So you just draw a representative terminal side down in quadrant 4, and that's how you determine where the angle is. So this is where theta is. Okay? Now, because I know that, and I know that the cotangent is -3, okay? This is -3 over 1 as a fraction, which means the x represents the 3, the y represents the 1, but the y has to be negative. So this is really 3 over -1. So I just told you that the x then is 3 and the y is -1. And so that's how you can get that triangle. It's based off of these clues. Okay? And so once I have that point, and then it's the same as the other stuff, and you can just find the trig functions based off of that. We got to find r, So r is the square root of x squared plus y squared. That's 9. That's 1. So this is the square root of 10. And then I can just do the rest. I'm not going to finish this one, but you're just going to write off the rules based off the definition. So this is all about how did I get this quadrant? How did I know it's in this quadrant? And how do I know what that point is? And it's all based off the definitions and comparisons to the values that they gave you. Question number 5 says that you have the sine of theta is 3/5. And then I tell you that theta lies in quadrant 2. So that's nice. I tell you what quadrant it's in, it makes it a lot easier. Okay? So I already know that my terminal side is over here somewhere. There is theta right there. And I have to find that point. So, again, by definition, I know what? That the sine of theta is y over r, which means y has to be 3 and r has to be 5. So I know that this value here is 5. I know in my point up here that the y value is 3, and y has to be positive because you're above the x-axis. R is always positive, but x is going to be negative. So how do I find x? Well, by Pythagorean theorem. Okay? R squared is x squared plus y squared. R we know is 5. I don't know x, and I know y is 3. So you just solve this for the x, and you take the negative value for it. You see what I mean here? This is 25 minus 9. So 25 minus 9 is 16, so x squared is 16. When I take the square root of both sides, I get plus or minus the square root of 16, or plus or minus 4. But I need x to be negative because I'm in quadrant 2. So I need the negative 4 for this problem. If it was over here in quadrant 1 with the same information but in quadrant 1, then I would take the positive 4 value for x because x is positive in quadrant 1. So you have to be aware of what sign values are, what the signs are in whichever quadrant you're in for x's and y. So once again, I have that point, then it just continues on and you write all the rules out by definition. Okay? Here's the last one, how they hide information from you. So now the terminal side of theta lies on this line, and it's in quadrant 3. Find all the values of the 6 trig functions by finding a point on the line. So here's how we do this one. First off, 2x minus y equals 0 is a line. If you put it in slope-intercept form by solving for y, you get y equals 2x. Okay? And this is a line that you can graph, and it's basically representing like in this fashion. Let's do it as a dotted line for right now. That's y equals 2x. It goes to the origin as a slope of 2, rise up over 2, right? Okay, so this is the dotted line of that. But it said only in quadrant 3, so it's like a restricted domain. So I only want this part right here. This is the terminal side of my line, or my angle, excuse me. I don't need that part of it. This, then, is how I know what quadrant it's in and how I draw it. It's on that line, okay, and it's in quadrant 3. They told me that. So this is the terminal side, okay? The terminal side of the angle lies on that dotted line, on that y equals 2x, but only in quadrant 3, so I only take the one apart in quadrant 3. So how, again, do I find a point? How do I get a point on this line? Well, I can get any point I want on the line. Just plug in an x value. So the x's are going to be negative because you're in quadrant 3. If I plug in negative 2, I'm going to get negative 4. So that's how I can get that point. I can plug in any number I want. But to get the simplest answers with the least amount of reductions that you have to do in your fractions, the simplest point to pick is negative 1. If I do the x is negative 1, then the y value is negative 2, and I can use that point, and that's the simplest point. Any other point you choose will require you to reduce fractions, causing extra work for you. So choose the 1 or negative 1 when you do this one. And then you now have the point, and you can go from there. Remember, when you do r, it is always going to be a positive value. Negative 2 squared. So that's 4, 1 is 5. This is the square root of 5. So r is the square root of 5, and you can answer the questions based off of that. So that's pretty much all that you're going to have to do. These are all kind of going to be test questions. A couple of these will be on your test. You want to make sure you know how to do those and how to get to all of these from all these clues. And be careful of your signs. Get the picture drawn in the right quadrant. Know the signs of the point. X's or Y's, positive or negative, depending on the quadrant you're in, so that you get the right signs in your work. Again, you can't get it right if you don't have the angle in the right quadrant. Your signs will be off. And so we'll do more of these together in class, and that's the end of this lesson.